Here's an example problem for us, and this might be kind of like example 8 on the practice quiz, but there's a small twist. What do you think the first thing we need is? Molarity. Yeah, well, but before we get to molarity, how do we calculate molarity? We will have to convert milliliters to liters, but more importantly, I didn't bring in a periodic table. That one's worthless for me. Oh, look, entropy's really taking control. Got it here. Barium, 137.33 summed with 2 oxygens at 15.9994 plus a hydrogen 0.101. Anybody beat me to the punch?
170.
No, I get 171.8. I'm going to start out with the mass of barium hydroxide. As Caden said, we need to convert that 800 mils to liters. There's 1,000 mils in a liter. That'd be that many right there. Well, molarity is moles per liter. I got grams per liter. 1 mole barium hydroxide, same thing as 171. And all the units do their thing. I'm left with moles per liter. Here we go. 0.345 divided by 0.875 divided by 1715. And I know this mass to 3 digits. Why don't I just round this to 3? What is the molarity? This might be what I print on the bottom, put a label on. Alright, now what is the hydroxide ion concentration?
Opposite of the log.
You're way ahead of me and skipping an important point. Oh, you're making it way too complicated. Here's what we need. We need a balanced chemical equation showing us what happened when we dissolve this. How many hydroxides do I need? 2. So on the bottle, I might print this, and I probably don't need an ice table. Well, let's just go ahead and make one. This disappears. I get some of this. How much of this do I need? 2x. And since there's not an equilibrium arrow, this goes to 0. If this goes to 0, what is x? Absolutely. Alright, so then how much of this do we have? Yeah, double that. So now we're cruising right along. We take this mass, dissolve it in that volume. We can straight up calculate the molarity. Now this is a strong electrolyte. In lecture the other day we said strong bases are either alkali metals, sodium hydroxide, lithium hydroxide. That's the only way we can get hydroxides into solution. Most hydroxides are insoluble. Alright, it all dissolves up, so there's really none of this. There's no solid. It's all gone into these ions, so this 1 to 2 stoichiometry, 2 hydroxides for 1 barium, is going to make our hydroxide ion concentration double. So now we can answer this other question. What is this solution's pH? This is the last thing I got in the register of my calculator. It's all unrounded in its glory. So I'm just gonna go, oh, I hit the log key. Man, I forgot the minus sign. So my PO8 is this. And actually I forgot the minus. So look, it says 0.2. So now I just get it hit plus 14.
Wasn't it positive? Forgot.
This is positive.
Oh, it was on your calculator.
Yeah. On my calculator, I got the negative. That allows me to go plus, and then that says answer 14, because I'm doing this thing right now. So we've answered this question. Answered all 3 of these. So a strong base, we might say a hydroxide ion is equal to the molarity. Base for things like sodium hydroxide, lithium hydroxide, potassium. So I told you this one would have a little twist. 2 hydroxides for every one of these. And then we did POH to get to pH. Any questions on that? Clear as mud.